Shwaya. In this video, we're going to learn a very easy way to find out the hybridization of any given compound within 10 to 15 seconds. What is hybridization? It's the intermixing of atomic orbitals having comparable energy to form equivalent hybrid orbitals. Now, to find out the hybridization, we need three information. The first one is valence electrons of the central atom. So we should know which one is the central atom, and we should know how many valence electrons are present in the central atom. The second information we need is valency of the surrounding atoms. So you may already know valency and valence electrons are not same. Valency is the combining capacity or binding capacity. The third one is, by knowing these two, we have to find out the steric number, and from the steric number we can find out the hybridization as given in the table. So if the steric number is 2, we will get Sp. So we already know. So for those who may not remember what is steric number or Sn, so this is number of bond pair and lone pair. So if the steric number is 2, it is Sp hybridization. If it is 3, Sp2. If it is 4, it is Sp3. If it is 5, it is Sp3d. If it is 6, it is Sp3d2. So if you add the power of these orbitals here in the hybridization, the addition will give you the, so 1 plus 1, the addition will give you the steric number back. So in this way you can confirm the hybridization you have deduced. So say for example, if you take the last one Sp3d2, so 1 plus 3 plus 2, 6. So you will get again the steric number back. Okay. So by knowing these three, we can easily get the hybridization of any given compound. So we will start the first compound, CO2. Central atom carbon, valence electrons 4. For each valence electron, draw a dot. The surrounding atom is oxygen. Its valency is 2. So since the valency is 2, combine 2 electrons and draw one line like this. So this leads to one bonded pair and this another bonded pair. So thus 2 bonded pair. There is no lone pair. Therefore steric number is 2. When the steric number is 2, that leads to Sp hybridization. Since there are no lone pairs, the shape will be ideal. Therefore it's a linear molecule. Moving on to the next example, BF3. Here the central atom is boron. Valence electrons are 3. So draw 3 dots. Fluorine is the surrounding atom. Valency is 1. So directly for one electron, draw one line. So this leads to totally 3 bond pair. There is no lone pair again here. Since the steric number is 3, this leads to Sp2 hybridization. Since there is no lone pair, the geometry will be trigonal planar. Moving on to the next example, CH4. Here carbon is the central atom, valence electrons 4, 1, 2, 3, 4. Hydrogen is the surrounding atom, valency is 1. So for one electron, draw one line. So this leads to 4 bond pair. There is no lone pair. So steric number is 4, and this gives me Sp3 hybridization, and the geometry will be tetrahedral. Moving on to the next molecule, phosphorus pentachloride. Here phosphorus is the central atom. Its valence electrons are 5. So draw 5 dots. Cl valency is 1. So 1. So 5 bond pair. There is no lone pair here. Steric number 5, and this leads to Sp3d hybridization, and this will be trigonal bipyramidal. The next example, S of 6. Here is the central atom. 6 valence electrons. Draw 6 dots. Fluorine 1 is the valency, so one line with one electron. So totally 6 bonded pair, no lone pair. Steric number is 6, leading to Sp3d2 hybridization. Since there is no lone pair, no distortion, perfect octahedral shape. Okay, so these are examples we had where we don't have any lone pairs. The next example what we are going to see, we'll have lone pairs. Let's see. The next example is ammonia, central atom, nitrogen, valence electrons of 5, draw 5 dots. Hydrogen, valency 1. So for one electron, draw a line. So these give 3 bonded pair, and we have one lone pair. So 3 plus 1, addition 4 is the steric number. For 4, Sp3 hybridization. Since we have lone pair, the shape will be trigonal pyramidal. Next molecule is water. Oxygen is the central atom. Valence electrons are 6. Draw 6 dots. Hydrogen, 1 is the valency. So draw 2 lines. So they give 2 bonded pair and pair up these electrons. Totally 2 sets of lone pairs. So 2 plus 2, 4 is a steric number, and this will lead to sp3 hybridization. Since we have 2 lone pairs, the shape will be bent. The next molecule is SO2. Sulfur is the central atom, belongs to oxygen group, so valence electron 6. Draw 6 dots. Oxygen valency is 2, so combine 2 electrons and draw 1 line. So 2 bonded pair and this 1 lone pair. So 2 plus 1, steric number is 3. If the steric number is 3, sp2 hybridization. Okay, this will be having bent geometry since we have 1 lone pair. Next molecule is SF4. Sulfur is the central atom. 6 is the valence electrons. Draw 6 dots. Fluorine, valency is 1, so draw 4 line like this. So this will lead to 4 bonded pair, and we will be having 1 set of lone pairs here. So 4 plus 1, 5 is the steric number. This will lead to sp3 dehybridization. Since we have 1 lone pair and 4 bond pair, we will be having seesaw structure. The geometry will be seesaw geometry or sawhorse geometry. The next molecule is HCF4. Xenon is the central atom. 8 valence electrons are there in xenon. Fluorine, 1 is the valency, so draw 4 lines for the 4 fluorine atoms we have in the molecule. This 4 bonded pair. Now pair them up. We will be having 2 lone pairs. So 4 plus 2, 6 is the steric number. For 6, sp3 d2 hybridization. When 4 bond pairs and 2 lone pairs are present, we will be having square planar geometry. So in this way, using such simple information, you can deduce the hybridization of any given molecules within 10 to 15 seconds. That's all. I'll meet you with some other interesting video next time. Thank you.